Welcome to the Explainer. Today, we're going to break down a really critical and honestly often misunderstood web vulnerability called server-side request forgery. You'll hear it called SSRF for short. All right, so to really get a handle on this, let's just forget about the code for a second. We're going to start with a simple story, an analogy, that gets right to the heart of the problem. Okay, so this is it. This is the whole thing in a nutshell. Look at the bad scenario. You walk up to a receptionist and ask them to grab a file from the CEO's office, and they just do it. No questions asked. You've just tricked a trusted insider into doing your dirty work. But now look at the good scenario. This receptionist, they've got a rule book, they check an approved list, see that the CEO's office is off limits, and politely tell you no. That simple difference, well, it's everything. Okay. So let's take that story about the two receptionists and connect it to the digital world. What is server-side request forgery, really? So here's the technical breakdown. SSRF is a vulnerability where an attacker basically tricks a web application into making network requests for them. The web server itself becomes our naive receptionist, the one who doesn't ask any questions. The attacker is just sitting out in the lobby on the public internet and tells the server, hey, go fetch this for me. And the server, well, it does exactly what it's told, not realizing it's being sent to grab something from a super restricted internal part of the network. And here's why this is so incredibly dangerous. Think about it. A request coming from inside the network, from the web server itself. While it's usually trusted, right? Firewalls, other internal services, they're all set up to think, oh, that's one of us. Let it in. So when an attacker pulls this off, they're essentially wrapping their malicious request in a cloak of trust. They're bypassing all the defenses that would have easily stopped them if they tried to attack from the outside. So how does this kind of thing even happen? Well, it usually boils down to a few key slip-ups. Number one, and this is the big one, no input validation. The application just blindly accepts any URL a user gives it. Combine that with a flat network where the web server can pretty much talk to everything else on the inside, and you've got a recipe for disaster. And to top it off, attackers can get really creative, using the server's ability to speak weird protocols, not just HTTP, to poke around in all sorts of unexpected places. All right, let's switch gears for a second. Let's think like an attacker. How do they take this one little flaw and turn it into a full-blown heist? So you're an attacker, and you found an SSRF vulnerability. What's the play? What can you actually do with this? What's the end game? Well, things escalate, and they escalate fast. Step one is reconnaissance. The attacker uses your own server as a spy to scan your internal network, mapping out all the other servers, databases, and services hiding back there. Then, with that map, they move to step two, access. They start hitting internal APIs, maybe find an admin panel that isn't password protected, or pull data from databases that should have been totally unreachable. But the final step, the grand prize, especially in the cloud, that's stealing credentials. They can hit these special metadata services and snatch the keys to the entire kingdom, potentially giving them total control of your cloud infrastructure. And look, this isn't just some textbook theory. Let's talk about a real-world case where a huge company had a very, very close call with this exact threat. Yep, we're talking about Shopify. Back in 2017, security researchers found a really critical SSRF vulnerability right in their main platform. So, get this. The way-in was a feature that seemed totally harmless, letting a user upload an image by just giving a URL. But instead of linking to a JPEG or a PNG, the attacker gave it a very special internal IP address, one that Amazon Web Services uses for metadata. And what does Shopify's server do? It acted like our trusted insider and dutifully went and fetched the data from that internal address, exposing super sensitive info about its own cloud setup and handing it right back to the attacker. Oof. The lesson from this whole incident couldn't be clearer, and it's a big one. You absolutely cannot, under any circumstances, blindly trust a URL that a user gives you. Every single one has to be validated. No exceptions. Okay, so we've seen how bad this can get. The question now is, how do we defend against it? How do we make sure our server is the good receptionist with the rulebook, not the one that gets tricked? Defense number one, and this is absolutely crucial, validate and whitelist your URLs. You have to be super strict about where your application is allowed to go. Don't even try to block all the bad places. That's a losing game. Instead, you create a very short, very specific allow list, a whitelist of approved domains or IPs. If a requested URL isn't on that list, the answer is always no. Simple as.
Second, you've got to segment your network. You need to build walls. Think about it. In a secure building, you don't just have one big open room, right? You have locked doors and restricted areas. Your network should be the same. Your public web server should live in its own little bubble, with strict firewall rules that stop it from talking to your critical internal databases and services. That way, even if an attacker does find an SSRF flaw, they're trapped. They can't go anywhere.
And defense number 3, disable any protocols you're not using. Your web application probably only needs to speak HTTP and HTTPS, right? Well, attackers love to use weird old protocols like file / to try and read files off the server's disk, or gopher / to talk to databases in strange ways. Just turn them off. By only allowing the absolute essentials, you shut down a whole bunch of creative attack vectors. So at the end of the day, it all comes down to this. We need to completely change how we think about our web servers. They aren't just faceless machines on the internet. They are trusted insiders on our network, like an employee with a keycard that opens almost every door. And that forces us to ask a really important question. Your server is a trusted insider. So who are you letting it talk to?